Yeah, hello everyone. Today we are going to have two main objectives. The first objective is to know the difference between polling and interrupts, and the second objective is to demonstrate how polling works using an MSP430 microcontroller. So let's begin. Firstly, we'll look at what a difference between polling and interrupt is. The main difference is that in polling, the CPU keeps continuously checking for the device status, whereas in an interrupt, the device signals an interrupt, and then the interrupt handler does whatever is needed, whatever processing has to be done. So of course, interrupts are more efficient and are used in a lot of modern OS. But for the sake of this assignment, we are demonstrating polling using MSP430 microcontroller. So let's get started. This is a code that will drive our microcontroller. Of course, the first two lines, it's to stop the watchdog timer and to another couple of boilerplate codes. Now, the key thing is that we are going to enable an input switch in port 2.7, which is exactly why we are setting P to dir. The direction is north of bit 7. So this, what basically happens is that uh, port 2.7 will be set as an input, and there will be a resistor enabled, pull-up resistor that will be enabled at that. What exactly does a pull-up resistor do? So basically, when the button is pressed, we have we have a low voltage state that is signaled, and when the button is not pressed, it's by default a high voltage state, and this can be seen inside the while loop now. So the main objective is that let's say we press the button 5 times, an LED turns on, and when we press it for the sixth time, it turns off, and it keeps repeating like this every 5 times in a cycle. So what we're going to do is we're going to initialize a counter variable here, which is initially at 0. And now what we're going to check is if the button is pressed, first we wait for some delay cycles. Why do we do this? Simply because the mechanical switch in the MSP430 microcontroller has a debounce, meaning that it keeps oscillating between the on and off state for quite some time. And once it stabilizes in the on state, that's when we again check whether the button is still pressed. Now, once we know that this button is still being pressed, we do whatever calculations we need to do. If the counter is 4, what we're going to do is we're going to flip the input state, and if the counter is 5, we're again going to flip the input state and set the counter as 0. So this is going to be the on state when counter is 4, and when counter is 5, basically we're going to flip it back into the off state. And at the end of the loop, we're going to, of course, increment the counter variable by 1 so that it keeps progressing. So the key part here is the XOR operation. P1 out will be off by default, and whenever we XOR by bit 0, we are just flipping the LED output. So that this core code will run for an infinite amount of time, and this basically sums up what we have to do in terms of logic. Now let's check whether this is actually working using a microcontroller. So let's continue with our MSP430 demo. So the first thing that we need to notice is what is our input and what's our output. So here we had set this particular LED as our output, and this switch P2.7 is going to be our input. So what we're going to do is every fifth time this button is pressed, the LED is going to turn on, and every sixth time it's going to turn off. So currently the LED is in its default state on. So now let me press the button 1, 2, 3, 4 and 5. So fifth time the button turned on, and sixth time it's turned off, and now 7, 8, 9 and 10. So this particular thing keeps going on in an infinite loop as long as the MSP430 board has a power supply. So this is the basic operation of a polling system. Here one thing that we need to observe is that the CPU of this MSP430 microcontroller is constantly looking for this particular input, the P2.7 port. So that is in reality the reason why interrupts outperform polling is that the CPU wastes a lot of processor cycles in just monitoring the state of this input. So which is why, there are more advanced versions, interrupt handlers that we develop. Since this is a microcontroller and has a more primitive CPU, uh, we can expect we can design a simple polling system instead. So that concludes our demo, and thank you.